So now that we remember what all the different numbers are, let's do one example here. So A, indicate the multiples of 5 and 10 from 1 to 500 using set notation, list any subsets, and B, represent the sets and subsets in a Venn diagram. So the name of the game here to begin with are always define sets. Okay, you can't just throw in a letter there and hope that the person that is looking at your work, most likely me, will know what you're talking about. So first things first, let's define our universal set. So we'll call this S. So S equals the set of all numbers from 1 to 500. So if we were to write this in set notation, we would say S equals X such that, okay, that's what this line represents, such that 1 is less than or equal to X, less than or equal to 500, and X is an element of the natural numbers. So that's saying that X belongs from 1 to 500, and we only have numbers that are natural numbers. So 1, 2, 3, 4, 5, 6, etc., all the way up to 500. So if I were to define F being set of all multiples of 5, we would define this using the set notation saying little f such that that f equals 5x. Now since we've defined x up here, we can use it again here without having to define it again. And we're going to say for x between 1 and 100. Why? Because what this is saying is it's giving you kind of like a formula. So if I would put in 1 into here, I would get the number 5. If I would say x equals 2, I would say, f equals 10, which is the next multiple of 5. And so on and so on. And you only want to go up to 100 because 100 times 5 is 500. You don't want this upper bound here to be 500 because then it would be 5 times 500, which would be greater than 500. And we're also going to say that x is an element of the natural numbers. This right here, I just want to draw it out a little bit. It's like a C with like that. So x is an element of the natural numbers. We kind of remembered, or we kind of used that notation last year as well. If I wanted to just pause for a second, I would say that F is a subset of the universal set because every multiple of 5 is contained in the set of all numbers between 1 and 500. Great. So we're going to say T equals the set of all multiples of 10. So we're going to use this as our template here. We're going to say T equals T such that T equals not 5x this time, but 10x, where x is between 1 and, can you guess what it would be? Yeah, 50. Because when I substitute 50 in for this x, 10 times 50 is 500. That's how big we want to go. And x is an element of the natural numbers. We can say that the set of all multiples of 10 is a subset of all multiples of 5. Because if I were to say multiples of 10, 10, 20, 30, these are all also multiples of 5. Is the same true the other way? 5, 15, 25. No. I couldn't say that F is a subset of, sorry, not an element. F is a subset of T. We couldn't say that because 5 is not a multiple of 10. So let's draw our Venn diagram. I'm just going to erase this here. So if I were to draw in this box, and let's just see what all of our sets are here. We have S, and we have F, and we have T. So S belongs here. F is pretty big. And all of the elements in T are found in F.